let's get started then. So, who am I? I'm Sam MacPherson. You may know me as Hexanaut online. I joined the MakerDAO community in January 2018 as a sort of just DAO community member. I was the first smart contract engineer to actually work for the DAO. I developed the peg stability module in August 2020. It was kind of a unique thing in that it was sort of developed under the DAO and not so much the Maker Foundation. I joined in the protocol engineering team since the inception of it in May 2021. So the agenda today is first I'll go over with the brief history of Maker as it relates to Keeper infrastructure. I'll go over Keeper operations, more of a deep dive into liquidations, followed by MIP63, the Maker Keeper network, and then going multi-chain. OK, so let's go back in history a bit. November 2019, multi-collateral DAI launches with ETH and basic attention token as the first tokens. DeFi didn't really exist at this time. It was basically just Maker on chain. Fast forward 4 months, we have the Black Thursday event. Some of you may remember, March 12th, 2020, when the price of ETH dropped about 50%, kicking off a massive amount of liquidations in the Maker protocol. It definitely pushed it to the limits. And somebody was actually able to exploit this with what we call a zero bid attack, where they were able to bid zero on a massive amount of liquidations all at once. And they were able to take all the collateral. So this sort of spurred on the development of a second version of liquidations, to which we wanted to address some of the problems and sort of take advantage of the evolving DeFi ecosystem as it was sort of maturing rapidly over this period of time. The next sort of major milestone in relation to Keeper network stuff is the D3M launch. We had been developing this with Aave. They were the first protocol we integrated with. Basically, this directly injects DAI liquidity into their protocol and sort of gives them nice rates there. We're doing the same thing with Compound now, which will launch soon too. And then MIP63, I created this in December of 2021 to sort of deal with this long tail of Keeper operations we need to basically do to maintain the Maker protocol. And then in the future, we're aggressively focused on going multi-chain. So this is going to be relevant for that too. So these are the 4 types of Keeper operations in my mind, sort of a mix of the 2 properties they have. So type 1, I call this incentivized and complex. The complex piece refers to the fact that you need to compute the operation off-chain. And the incentivized piece refers to the fact that there's MEV available or maximally extractable value. Yeah, so an example of that is like starting liquidations on liquidations 1.0. Second piece is incentivized simple. So the incentivized piece, MEV, is available. And the simple piece is that it can be computed entirely on chain, which is nice. So example of this, liquidations 1 and 2, complete liquidation, interest accrual, surplus auctions, and there's others. Type 3, non-incentivized complex. So basically means there's no MEV available. So the protocol needs to pay for these operations. And then we have non-incentivized simple, which is on-chain, protocol pays. So I'll get into these in detail. So let's go over the type 1. This is incentivized complex. So here's sort of a sample Keeper where they need to monitor basically a lot of vaults. In Maker, we have over 10,000 vaults. So this is definitely not something you can compute on chain. You need to basically be every block watching and seeing which vaults are underwater, and if they are, sort of kicking off a liquidation event. The reason this is incentivized is there's actually, and this is under liquidations, the original one. It's incentivized because you could actually pair the operation with a bid such that you would very likely win the auction. So that's why it ends up being incentivized in this case. Type 2 is incentivized but simple. So for example, this is liquidations 2.0 sort of bidding an auction, basically. So there's 3 auctions up for grabs. And one of them becomes available with a profit to your keeper, you can basically just evaluate this entirely on chain, and this is due to the fact that there's a small number of auctions, like 1 to 10 kind of numbers. You can do this entirely on chain, and then you execute it, and you get some MEV, you get some profit. Non-incentivized complex, this is, again, we have a lot of vaults we're monitoring, but this is for liquidations 2.0. It's non-incentivized because this same trick where if you kick off the auction, you have an advantage in the winning the auction does not exist for liquidations 2.0, but it's similar. And then the final one, non-incentivized simple. So this would be something like just updating the link price oracle. It has to be done for the protocol security, but who's going to do this? You have to pay them, basically. So here is more of a deep dive on the liquidations. So on the left, we have the English auction system, and on the right, we have Dutch auctions. So liquidations 1.0. This was running under the English auctions. So this is kind of split into a 2-stage process. The first stage, basically anybody's invited to bid some amount of DAI for the collateral, and this will just increase to some maximum bid. The interesting thing here is, so as this was developed in sort of DeFi, before DeFi, there was no instant liquidation, no liquidity pools, none of this. So we basically needed people to participate that had basically piles of capital sitting around that they could lock up for 30 minutes at a time on each of these auctions, which made sense at the beginning, but I'll explain why this doesn't make so much sense now. And then the stage 2 part of that, not so important, but it's users can bid less amounts of collateral that they'll get for the winning, the maximum bid of DAI. The Dutch auction system, on the other hand, what it will do is it will start at some price above the market price, and at T+1, T+2, it'll just basically tick the price down until somebody says, I'll take this, and they can take a profit. So when that happens, they can basically settle out the whole auction instantly without having to put up any collateral, which is super nice. All right, so yeah, Liquidations 2.0 was definitely a necessary upgrade. We had a lot of problems with the first version. As I said, it was built before DeFi existed. MEV wasn't really a thing. It required capital lockup, and there was this zero bidding exploit. The auctions are completely unaware of the market price, which can be bad. So we upgraded the Dutch auction system. We added flash loan support to maximize participation. This basically allows people to, execute the, clear out the auction, finalize the auction, and then put it through something like Uniswap, where they basically don't have any collateral on them, and sort of democratizes access to the auctions, which is a very good property. So the auctions these days are now a very healthy ecosystem of incentivized actors. There's no need for the protocol to pay anybody. They get paid out of the profitability of the auction. And yeah, far more participation without capital requirements. So that basically covers type 1 to 3 I went over. So for type 4, I was noticing there was sort of this long tail of basically maintenance operations that fall into this type 4, where they're not automatically incentivized, and they can be evaluated on chain. So this led me to develop the Maker Keeper network, MIP63, in December of last year. Basically, the idea is we have a network of networks. So we sort of have this sequencer on the Maker side, which every 13 blocks, it will rotate between, we have now 4 Keeper networks participating in this. So we go between our own internal tech ops team, which runs their own keepers. We use Gelato, we use Keeper Network, and we use Chainlink. So it will rotate between these Keeper networks, and then these Keeper networks usually do a similar pattern of rotating between their individual keepers at the end. And so the idea is on the top part, you see we'll list job 1, job 2, job 3. We define sort of these jobs on chain, what we want to evaluate, whether it should be executed, and when it's ready to be executed, who should be executing it. So in this example, we have, let's say, an Oracle update. It needs to be run, job 1. The sequencer has told Chainlink that they are the active network that should be executing this, and Chainlink in turn will tell the individual keepers, it's your job to be executing this now, and then they should be executing this in a timely fashion. So we sort of follow this pattern for the jobs. We have this more expensive check with Workable. I think this pattern is actually used fairly heavily around all Keeper infrastructure. But basically, you could do like more expensive checks, not crazy expensive, but like reasonably expensive, like looping over a bunch of stuff, checking a whole bunch of properties and stuff like that. And then when this function returns true to the Keeper, it's their job to execute the work function. So this should be gas optimized and very, very concise, because this will be executed on chain. So yeah, and the last piece is sort of paying for gas. How we do this, it's kind of split between our own internal tech ops team and the external networks like Chainlink. For the Maker internal tech ops team, they have sort of their own custom management of gas and budgets and stuff like that. For the external networks, basically they have to like maintain a buffer of DAI, and then when that buffer gets too low, they'll use the same Keeper infrastructure to automatically top it up for the Maker treasury, which will sort of give them allocation of DAI. And it's up to the internal mechanics of the network to translate that into whatever the gas token is, ETH or what have you. So yeah, and for the future, as Maker goes multi-chain, it's kind of our goal to reduce complexity, simplify, sort of, and get this sort of massive redundancy across all these networks such that we can be confident that the network is secure, even during adverse conditions. Simpler is better. I think that's the bottom line. So yeah, thank you.